This is Math Center. Welcome all math fans. It's a beautiful day here in San Antonio, Texas, and we've got a doozy day of math for all of you. Today we've got some intro to evaluating rational expressions for you, and even though it was a long, grueling road through our previous unit of rational functions, we've got some highlights from some superstar mathletes to help you through it all. Lois?
Well, mathletes across the world have been confined to their own homes, but that doesn't mean they aren't still perfecting their craft. Let's see how renowned mathlete Crisscross Applesauce tackled this warm-up rational exponent problem.
Well, the square root of 9 I can rewrite as 9 to the 1/2 power. So, then, I know the square root of 9 is just 3. So, 9 to the 1/2 power is just equal to 3.
Did you hear the grit in that kid's voice?
I did, Matt, and not even a calculator.
No calculator needed for mathematics. Well, you thought that was good. A young girl from Chicago, Illinois, Nies Obies, seamlessly solves this next review question.
Well, if I have 8 to the 1/3 power, then I know that just means the cube root of 8. So I know the cube root of 8 is 2, because 2 times 2 times 2 is 8. So that's how I get it done.
Did you see how she made the fraction a cube root symbol?
Amazing. Don't let that sweet voice fool ya. She is a math machine.
Math magician.
What extraordinary mathletes we have out there. Truly remarkable. Just the confidence these young adolescents exude is infectious on all levels, Matt. But it doesn't stop there. We have the 7 to 9-year-old exponent champion, Quentin Quarantino, solving a variable expression.
Well, if I have a over b, which is just any number over any number, well, if I take that to the -1 power, that just means that negative in that power in that exponent just means that I'm going to flip that fraction. So a over b just becomes b over a to the first power, which anything to the first power, that's just going to be itself. so it's just b over a. Yeah.
I see why they call him the exponent champion, Matt.
You just know that young kid has gotten his lunch money stolen a time or two. Oh, man. Well, to conclude today's episode of Math Center, we will head over to the dusty, rough farm roads in Odessa, Texas for our final highlight from Titus Ray Chickensworth. Well, when I got a 5 in the parentheses right there, and I got that -1 exponent, it's going to be a little different than when I've got these guys over here, this fraction, because I don't have a fraction right here. So I've got to make me a fraction. So 5 as a fraction is just 5 over 1 to that -1 exponent. And then that negative in the exponent just means I'm going to flip-flop that fraction, take the reciprocal, if you will. So when I take that, I'm going to get a 1 over 5, because I've just flippity-floppity that fraction to the first power. But then we all know anything to the first power, it's just going to be itself. So that answer is just going to be 1 over 5. And that's that.
Would you look at the technique, Matt?
Well, he didn't shy away from that one. You could say he's no chicken. Oh, Titus Ray Chickensworth, what a character. Well, that's it for us here at Math Studios. We hope everyone is staying safe and quarantining wisely. Until next time, this has been Mathematics
And Lois Carmen, denominator.
reminding you that math is indeed awesome. Good night, everybody.
Stay safe in there.
All right, guys. Well, I hope you guys enjoyed that episode of Math Center. Let's get started with the rest of the video notes. So this is week 5, Thursday. So we're actually going to start a new unit, and this is just taking that rational stuff to the exponent, right? So basically, you're always going to have a fraction as an exponent now. You guys are used to like 4 squared, 3 squared, or 4 cubed, something like that, which are really just look like this, really basic, like 4 cubed. You guys are used to that stuff. You're also used to just like the square root of 4 or the cube root of 8, right? Just seeing it that way. But there's other ways of writing those, right? And that's what we've kind of introduced you to now is fraction exponents, right? So that's what we're going to talk about here today. Before I get into that, guys, it's very easy to get mixed up with which whether the numerator or denominator of that fraction exponent, what they mean. So whenever you have that fraction as an exponent, does the numerator, is that the actual exponent, or is it the radical, right? The numerator or the denominator, each of each, right? So what I want you guys to remember is when I have a number, a base number, I'm just going to call it 1 for now. Whenever I have that base number, when I raise it to a fraction, right, I want you to think of something. So there's two things. You have an exponent up there and you have a radical up there, right? Radical just means what you're taking the square root of, the cube root of, whatever, right? So I want you guys to think to yourself, what is easier to say? Is it easier to say square, and I'm sorry this is going to look so bad, I'm writing small. Actually, I can do this to make it better. That's embarrassing. So square, is it easier to say, square root? Or is it easier to say root square? Now, this is just the way that I learned how to do this. So this is that fraction exponent we're talking about. And when I say easier to say, I don't mean like, can you say it? Obviously, you can say both. We all speak English, right? But which one seems more natural? What have we heard more in math, right? We never hear the term root square, ever. We always hear square root. And so since we read top to bottom usually in English, right, that'll help you out a lot. So root square is not what you want to say, right? That's a no-go. What you want is, hang on while I get this and check mark it. What you want is square root. So that exponent is going to be on top while the radical is going to be on bottom. And I want you guys to kind of look up here and see that square root means I have it to the first power, which doesn't affect anything, but I have a cube root, the third root, which is what we translated it to here, right? Do y'all see that? So as we go through, just make sure you're remembering that part. So let's get started over here with 81 to the 3/4 power, right, to the 3/4 power. Really quick, I'm going to write this every single time, just so that you guys get familiar. But remember, it's square over root, right? So this one here is going to be 81 to the 3rd power and then the 4th root. That's all it's saying. So first of all, let's rewrite this, right? Let's rewrite this. And we always want to take that root first if we're going to do this without a calculator because it's going to be that much easier to do. So let's pick red here. So I'm taking the 4th root. So let's write this right next to it. 3/4 is what we're taking this exponent to. So I'm taking the 4th root. So I've got this 81 to the 4th root. And then after I take that, I'm going to cube it. So that's what I mean by square root. Obviously, you're not always going to square something, right? That's only when there's a 2 up there. But when you think squared, you think exponent. So that's what let's actually write that here. Let's just put in parentheses here, exponent. Because it's not always going to be squared, right? In this case, it's cubed, right? But that just gives you an idea so you don't get mixed up with these, right? So I have 81 to the 4th root, and then I've got to cube it after that. Well, 81 to the 4th root is going to be 3, right? Because 3 times 3, since 3 times 3 times 3 times 3 is 81, right? 3 times 3 is 9. 3 times 3 is 9, and then we know 9 times 9 is 81. So since 3 is the cube root of 81, that's going to be my answer on the inside. Then I'm going to take that 3 and then cube it. So 3 cubed is 3 times 3 times 3. That's going to be 9 times 3. That's going to be 27. So my final answer there is a whopping 27, right? So this turns into a very simple problem once you understand what is happening up here, right? This 3/4 power is really just telling me to take the 4th root of it and then cube it after that, right? 4th root and then cube it. And that's exactly what we did. We took the 4th root of it, that was 3, and then we cubed it, got 27, right? Simple as that. So let's move on to number 2. Right, so I've got negative 64 to the 4/3. And again, remember, it's square over root, exponent over root, right? So let's do it. So I've got a negative 64, and again, I always want to take the root first. Sorry, this is messing up. negative 64, and I always want to take the root first, so the third root of that. And then I want to raise it to the fourth power afterwards, right? And so the third root, the cube root of negative 64, is going to be a negative 4. Why? Because negative 4 times negative 4 times negative 4 is going to give me negative 64, right? And then that to the fourth power doesn't just go away. So negative 4 to the fourth power is going to be negative 4 times negative 4 times negative 4 times negative 4. Negative 4 times negative 4 is positive 16. Positive 16. So 16 times 16, I don't expect you guys to know that off the top of your head, but it is going to be 256. There you go. It becomes a very easy problem, guys. Once you guys understand what this fraction as an exponent means, you can easily rewrite it, and then you can solve, right? It's pretty simple. You guys are used to solving things like this, and then you're used to solving things like this. So really, there's nothing too new here after you understand what that fraction of an exponent becomes, right? Then you just take it step by step. Okay, now let's get down to number 3. So we've got 16 to the negative 7 over 4. And if you remember from the Math Center episode, that negative exponent, you should remember from previous learning as well, but that negative exponent is actually going to mean I need to flip whatever I'm taking an exponent of, right? So again, I'm going to rewrite this in parentheses so that you can see it a little bit better. So I've got 16 raised to the negative 7 over 4. All this does is say I've got to flip what's on the inside of these parentheses. I've got to flip it. Right, so flip. Got to flip that. So I've got to make that 16 a fraction first, which just putting it over 1 makes it a fraction. And then in order to get rid of that negative in the exponent here, I've got to flip. So that's exactly what I'm going to do, right? So I'm going to come down here, and this is going to be my new equation. I've got to flip that 16 over 1 and make it 1 over 16. And that's what gets rid of that negative exponent. Negative exponent. So all I've got left is 7 over 4 as an exponent. Right, so all that negative exponent does, all that negative in the exponent does is flip your base number. It just flips it, that's it. Doesn't affect anything else. So once you flip that base number, that negative can go away, and you can solve it just like we've been solving numbers 1 and 2. Right, so again, I've got exponent over root. So I'm going to write the root first. So let's write it. So I have 1 over 16. That's a 6. That's a 6. To the fourth root. And then I've got to raise it to 7 afterwards. Now, this is going to be a little bit more work, but again, just take it step by step, guys. Look at what's on the inside of the parentheses. The fourth root of 1 over 16. That's something we can all do, right? That's something we all know how to do. So when I take the fourth root of 1 over 16, well, the fourth root of 1 is just 1, and the fourth root of 16 is 2. So now I've got 1/2 to the 7th power, right? 1/2 to the 7th power. Now, that just means I'm multiplying 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times 1/2, right? 7 times. Hopefully that was 7 times. I'm not going to play this back and check, but you should get it 7 times, so let's write it. 1/2. 1/2, 1/2, and again, this is super tedious, but just to show you that it's pretty easy. That's 6, and 1 more is 7. Then you just can start combining these 2's, right? You can start combining these 2's. So 2 times 2 is 4, right? And then times another 2 is 8, and then times another 2 is 16, times another 2 is 32, times another 2 is 64, times another 2 is 128. So this answer is 1 over 128. And that's just because I did 2 times 2 7 times, right? So there you go, right? Not too bad, not too bad. Remember that negative exponent just flips, and then you break it down into 2 problems, right? You got to take this cube root of 1 over 16 first. I'm sorry, not cube root. This fourth root of 1 over 16 first. And then once you get the answer to that, then you raise it to that exponent of 7, right? Just break this problem down, guys. Do it step by step. Don't take it all in at once. Don't overwhelm yourself, right? Take it one step at a time, and you should be just fine for these, okay? Finally, down here, just a couple more. We just want to rewrite these expressions. We don't want to solve them. And this is just some quick practice for you so that you understand what's happening, right? So I've got this first one, this 7th root of 4. And then I've got to the 5th power, right? So the 7th root of 4, I know root goes on the bottom. So I have a 4, base 4. I know the root goes on the bottom. And I know the exponent goes on top. So this rewritten is just 4 to the 5 over 7, right? 4 to the 5 over 7. Right? Not too bad. Not too bad. Now, I've got 1 over 9 to the 4th. Now, this one might be a little bit tricky because we know what to do when there's a negative exponent up there, but how do we write a negative exponent? Well, this one, we know we can take a reciprocal of something and raise it to a negative exponent, right? So really, I can flip this. So I have 1 over 9 to the 4th, right? I can flip that. I could say, okay, well, let's flip this and put a negative exponent outside of it. So if I were to flip it, I would get 9 to the 4th over 1 to the negative 1st power, right? Just a negative exponent up there. And then anything over 1 is itself. So really, I've got 9 to the 4th to the negative 1st power. And then a power raised to a power is just multiplying those. So this rewritten is just going to be 9 to the negative 4th power. Right, that one's going to be a little bit tricky. So I encourage you to kind of rewind this, play it back, make sure you understand it. But yeah, it's, once you go backwards, you can see how it's pretty simple. But that's just rewritten right there. Right, and then finally down here, negative base does not mean negative exponent. Right, so I've got a negative base, but I do want to make a negative exponent because I have something in the denominator that I don't want. Right, I have that radical. So I've got to flip this first. So again, it's going to be the same type of thing. I've got a negative out here, 4th root of 10, right? First things first, I want to flip it. I want to make sure that that's going to be upright by itself. So I've got a 4th root of 10, a negative 4th root of 10, raised to the negative 1st power, right? And that's what just got rid of that fraction right there, right? Now, I've got to make that radical of fraction in the exponent, right? And remember, the root goes on bottom. So I'm going to have the exponent of negative 1. So I've got negative 10 with the exponent of negative 1 and then a root of 4. And there you go. Right? There you go. So again, these last 3 guys are going to be, they're not too bad, but you just got to see them a couple times and work them backwards. Go from here to here, and then to here, and then to here, and then back to our original problem, right? Work them backwards. Again, go from here to here, and then to here, and that's our original problem, right? You can see it both ways, but make sure you play that back a couple of times. Hopefully you follow along, and then try them yourself on those big ideas. So outside of that, guys, hope you're all staying healthy, staying well. Yeah, so have a good day.